Is my screen is clear? Please confirm me.
Yes, sir.
Okay, fine. Okay, let's we will calculate some fast. Okay, થોડું આજે fast ગણીશું કેમ કે આપણે બહુ બધા examples cover કરી લીધા છે. Is it okay? Is it okay? Okay, and I hope all of you are sitting with a calculator. So again, our data is like this. Calculate. Calculate slope. Slope at support. And slope and deflection. Under the point load. Or beam. Given a below figure. Consider E equals to EI equals to 3000 kilonewton per meter square. This is exactly your data, and this is your beam. Sorry. And this is the most probably last example of the topic. Okay, this all example based on Macauly's method, by using Macauly's method. Okay, first of all give me a values of the support reaction. Chalo first. चलो मैंने पहला सपोर्ट रिएक्शन VA ना VB कैलकुलेट करिए आपको. Here is your VA, here is your VB. So can I say that sigma Fy equals to 0? I am mute to all of you. Okay, કોઈના ક્વેશ્ચન હોય તમને પૂછજો. Write down answer in chat box. Write down answer in chat box. What is the value of V and what is the value of VB? Plus VA minus 50. Now, can anyone tell me 20 kN moment to be considered in sigma Fy? Yes or no? Please give your answer in chat box because all of you are mute now. તમારામાંથી કોઈ mute નહીં થઈ શકે. Please give me answer in chat box. 20 kN ની moment ને મારા sigma Fy માં ગણવાની છે કે નથી ગણવાની? Fast. Okay. I want answer from all the students. Okay, fine, good. Only 3 people giving me answer. Please participate. પછી એવું ના થાય કે મારા બધાના કેમેરા ચાલુ કરવા પડે. Okay, fine. So minus 50. Now convert uniformly distributed load into the point load. Minus 40 into 3 plus VB minus 80, that is equal to 0. So can I get VA plus VB? VA plus VB equals to 4 3 વાર 120 ને 50 સામે જશે એટલે પ્લસ થઈ જશે 170. 170 plus 80 250. Sorry. Yes, 250 is the right answer. Number Y no moment here. We are considering sigma Fy. That is the algebraic summation of the all force, and 20 kNm is the moment. That's why we will not consider in sigma Fy steps. Okay, is it fine? Now take moment of all force about point A. દરેક કોર્સની મોમેન્ટ A આગળ લો. Clockwise positive, anti-clockwise negative. 80 into 8 clockwise, that's why positive. 80 into 8 clockwise, that's why positive. Okay, minus VB into 5, minus VB into 5 plus, first of all, convert uniformly distributed load into point load. That is nothing but 40 into 3. Just a minute, hold. Hello. कौन बोलो? Okay, sorry. 40 into 3 into 3.5. Yes or no? Is it okay? 40 into 3 into 3.5 plus 15 into 2. Minus 20. That is equal to 0. Please give me value of the VB. चलो VB की value आपको माने. What is the value of VB? Please check. One student giving me answer 228, others giving me 234, one more giving 232. चलो मैंने right answer आपको. फरी बार गणो. Please calculate again. 228 answer coming again. Okay, what's for 228? Third answer for 228. 234. Okay, 234, 228 ના પણ ત્રણ આન્સર છે. Four value for 228, 234 for 3. One more answer 229, 232. What happened? સાચો આન્સર આપો મને. ચલો right answer is a 228 kilometer. Okay, right answer is a 228 kilometer. Are you up to this or clear for all of you? Okay, so VB equals to 228 kilometer. Put this value in equation number 1. You will get value for VA, that is nothing but 22 kilometer. Is it okay, students? Please confirm me. અહીંયા સુધી clear છે બધાને? અહીંયા સુધી clear છે? Okay, અહીંયા સુધી બધાને clear છે? Please confirm me. Okay, fine. I am removing the calculus support reaction calculation. Okay, so now we will prepare equation for mx. mx બનાવી દઈએ. હું તમને mx બનાવી આપું છું. આ એક્ઝામ્પલ તમારે એસાઇનમેન્ટમાં લખવાનો છે. ઓકે, આ એક્ઝામ્પલ તમારે એસાઇનમેન્ટમાં લખવાનો. તમારે પોઈન્ટ A અને પોઈન્ટ B આગળ સ્લોપ શોધવાનો. પોઈન્ટ C અને પોઈન્ટ D આગળ સ્લોપ ડિફ્લેક્શન બંને કેલ્ક્યુલેટ કરવાનો. This example as a part of your term work. I am calculating mx and I am giving hint to all of you. પછી આગળ શું કરવાનું તમને હું કહી દઉં, પછી તમે આ એક્ઝામ્પલ જાતે સોલ્વ કરજો. Okay, so now let me calculate mx. Now can anyone tell me to calculate mx in which portion we have to cut a section? mx calculate કરવા માટે કયા પોર્શન આપણે સેક્શન કટ કરવું પડશે? Can anyone tell me in chat box? Yes, right. So we have a cut a section in B to D segment. Is it okay, students? Please confirm me. To calculate mx, we have a cut a section in a B to D segment. Is it clear? And this distance is nothing but x distance for you. Now let me calculate this distance. કેટલું હશે? ચલો, કેમ ખબર ના પડી મિત્ર? I am giving you a mic, right? You can ask a question.
સર
બોલ.
સર બીજી ડી માં કઈ સેક્શન કટ થશે ખબર ના પડી સર.
તો તારે ક્યાં સેક્શન કટ કરવું છે કે પહેલા? ચલો પછી હું તને સમજાવું.
એટલે સર કઈ રીતે એ નથી, એનું ખબર નથી પડતી.
સેક્શન કટ કરવાનો રૂલ શું છે? What is the rule for cutting the section? Section cut કરવા માટેનો રૂલ કયો છે? Can you tell me? What is the rule for cutting the section? Can anyone write down in chat box by selecting choosing everyone? Everyone choose કરીને લખી દો. So some more people can able to understand. As per our discussion in the very first lecture of the Macauly's method, I have already told to all of you, we will cut a section at a point where maximum number of pores will be covered. And this rule is applicable for throughout the Macauly's method. Either it is a simply separated beam, or it is a cantilever beam, or it is a overhanging beam. Is it okay? Please confirm me. I am repeating my statement. Whenever we are using the Macauly's method, we will cut a section at a point where we will cover a maximum number of forces. જે સ્ટુડન્ટ હજુ પણ ખબર નથી એ સમજી લો. If I am cutting the section in between A to C, can anyone tell me from left hand side how many number of force will be available to take a moment? Write down in chat box. Okay, now tell me, this rule is fulfill or not? This rule is fulfill or not? Can I take a section in A to C? Can I take a section in A to C? No. Now second portion is a C to B. If I am cutting the section in between C to D, now tell you me how many number of forces will be available from left hand side to take a moment or to consider the moment? Again VA 50 20 3 force 20 ની મોમેન્ટ પણ આવશે ને, 20 ની મોમેન્ટ પણ આવશે. ઓકે, and UDL uniformly distributed load in between suitable beam section cut કરી. So again can I say that your UV forces remain and 80 kN forces remain? So can I say that હજુ પણ કઈક મિસ થઈ રહ્યું છે? Yes or no? Please confirm me. And if I am cutting the section at point D, suppose point D આગળ section cut કરીશ અને left side થી moment consider કરીશ. So can I say that 80 kN load does not create any moment or does not produce any moment at point D? Yes or no? Everybody with me? If I am cutting the section at point D and considering the moment from left hand side, can I say that 80 kN load does not does not produce any moment? So can I say that I am free to cut a section in between B to D anywhere? So it will fulfill our requirement like that. The maximum number of forces will be covered for a moment. Is it clear, students? Please confirm me. Is it clear? Okay, fine. So now one of our rule is that whenever we are considering the section, up to section, our uniformly distributed load must be extended. Yes or no? I think this concept is already covered in previous lectures. Please confirm me. Whenever we are considering the section, our uniformly distributed load must be extended up to the section. Please confirm me quickly. First, I am replying from all of you because I am able to understand all of you are knowing this particular concept. Okay, so in this case, we have extended this uniformly distributed load up to the section. If I am adding this uniformly distributed load up to section, then I must have remove this uniformly distributed from that particular portion. Yes or no? So both value is not both value are remain same. That is nothing but 40 kilonewton per meter. That is nothing but 40 kilonewton per meter. Okay. So now can anyone tell me what is the value of this distance? What is the value of this distance? Yes, why 1.5? We are calculating all the distance in x term. You are absolutely wrong. Yes, that distance is nothing but x minus 5. Again, જેને ખબર નથી પડી એના માટે આ distance સમજી લો. પછી ફરીવાર હું નહીં સમજાવું. Last time સમજાઈ રહ્યો છું. This is a C point, this is a B point, and this is your section line. Actually, this is your x distance. So can I say that at this point x equal to 0? This distance is 2 meter, this distance is 3 meter, and this distance again 3 meter. Okay, can I say that x equals to 2 meter here? Can I say that x equals to 5 meter? And this is x equals to 8 meter. Everybody, please confirm me. Is it clear or not? So now, can I say that this distance is nothing but x minus 2? Yes or no? Simple. Total x છે એમાંથી આ 2 મીટર સબટ્રેક્ટ કરીશ તો મને c થી x નું ડિસ્ટન્સ મળશે કે નહીં મળે? પ્લીઝ કન્ફર્મ મી. જે લોકોએ રોંગ આન્સર આપે છે મને ખાસ કન્ફર્મ કરે. Is it clear or not? How I have to calculate the distance? Similarly, from point B, this distance is nothing but total x છે. Again, total distance is x. I have removed this distance. That is nothing but 5 meter. So my distance is nothing but x minus 5. Is it okay? Please confirm me. Please confirm me in chat box. Okay, fine. So let me calculate mx. Let me calculate mx first of all. So mx equals to plus va into x minus 50 into x minus 2. Yes or no? First dotted line va પછી આવશે. તમને બધાને ખ્યાલ છે dotted line ક્યાં કરવી. So I am not discussing now. Now you have already moment at point C. Nature of moment is anti-clockwise. That's why minus 20. As per our discussion in previous lecture, Macauly assumed that whenever we are considering the moment at a particular point, we need to write down moment in terms of the x. But ideally, moment by itself as a moment. Okay, so basically we does not require any distance to multiply with it. But whenever a moment is available in your particular problem, you need to consider write down a value of moment in terms of the x raised to power 0. So ultimately our multiplying constants become 1. Everybody with me? Please confirm me. Okay, so I hope it is clear to all of you. Into minus x minus 2 raised to 0. Why x minus 2? Your moment is acting at point C. From point C to section distance is x minus 2. Okay, and raised to power 0. So can I say that I have putting the value of moment, only value of moment. I don't have considered any distance. Again, this is your dotted line. Again, from point C to point to section above the beam, we will consider full UDL, and its nature is anti-clockwise. That's why minus 40 into x minus 2. That is the point load. Let me explain here. This is your total load. Distance is nothing but x minus 2. This total UDL will be acting at center of this length, and this distance becomes x minus 2 divided by 2. Is it clear, students? Please confirm me. Into x minus 2 divided by 2. Okay, x minus 2 divided by 2. Is it clear, students? Please confirm me. Okay, fine. Next is a VB force. Let me consider moment of VB force. The direction is a clockwise, plus VB into x minus 5. VB into x minus 5. Okay, that is a clockwise movement. From point B to section, that distance is a x minus 5. And last force is a uniformly distributed load. And moment of this uniformly distributed load will produce in a clockwise direction. That's why again plus 40 into x minus 5, that is the point load, into x minus 5 divided by 2. Is it clear, students? Please confirm me. This distance is x minus 5. Your point load will be acting at center point, and this distance is nothing but x minus 5 divided by 2. Is it clear, students? Please confirm me. So, so you have put this value in your in general equation. EI d square y by dx square equals to minus mx. આગળના કેલ્ક્યુલેશન આવડશે બધાને? આગળના કેલ્ક્યુલેશન આવડશે બધાને? Please confirm me in chat box. Let me put આપણે equation લખી દઈએ ખાલી minus 22x. You can ask. I am giving to your mic rights. Just a minute.
Hello, sir.
Yes.
Sir, તમે જે આ UDL B2D માં એડ કર્યું ને ખબર ના પડી મને.
B2D માં એડ કર્યું. Macauly's method એવું કહે છે કે તમે જે જગ્યાએ સેક્શન કટ કર્યું હોય, ઓકે, ત્યાં સુધી યુનિફોર્મલી ડિસ્ટ્રીબ્યુટેડ લોડ એક્સટેન્ડેડ હોવો જોઈએ. આપણા ડેટામાં એક્સટેન્ડેડ હતો?
ના નતો સર.
ઓકે, that is the reason, that is the one of the assumption. ઓકે, હું તમને જો ડાયરેક્ટ assumption ભણાવું તો ખબર પડે નહીં, એટલે હું જે અગેન આ મોમેન્ટની જે વેલ્યુ છે ને, that is also one assumption. So you need to write down a moment in terms of the x raised to power 0. That is also one assumption. Second, just a minute. Listen to me first of all. Okay. I am discussing some theory part. Now the question પૂછ્યો. First assumption is that moment should be written in terms of the x raised to power 0. X minus a raised to power 0. Second assumption is that your UDL must be extended up to the section. Third assumption is that we will consider origin on left side. Origin on left side. Fourth assumption is that we will write down all constant in first part. So now this assumption is covered here. Please confirm me. Yeah, clear થઈ ગયું? Give me answer. This is for all of you. બધા માટે છે. First assumption મેં શું કીધું? We will consider moment in terms of the x raised to power 0. That is the one assumption of the Macauly's method. We have apply here. Yes or no? Please confirm me. Second assumption is that we need to extend uniformly distributed load. We need to extend uniformly distributed load up to the section. In your given data, uniformly distributed load is given up to point B only, but we have a cut a section at in between B to C. Now, can you tell me in between B to C there is any UDL or not? UDL છે નથી. That's the reason to fulfill the assumption of the Macauly's method, we have extend the uniformly distributed load up to the section. Now it is clear. Please confirm me. If I am extending the uniformly distributed load of those sections, so I need to remove this uniformly distributed load from extended UDL. So ultimately, can I say that logically I don't add any uniformly distributed load? Please confirm. Is it clear or not? Harshvardhan? Are you there, Harshvardhan? Harshvardhan, is it clear or not? Okay, fine. Okay, now another assumption is that origin is on left side. Now, uh, just consider here. While I am considering the distance, calculating the mx, I have considered distance x from left side. Yes or no? The left side is section નું distance consider કર્યું છે. કહી શકાય? Please confirm me. So can I say that my origin is on left side? This is your third number assumption. And while integrating the term, we have putting the all the constant on a first part after vi into x. Yes or no? Please confirm me. Yes or no? Please confirm me. દરેક એક્ઝામ્પલમાં va પછી that means first part માં મૂક્યા છે constant. So these four are the assumptions of the Macauly's method. All of you are clear about this? It is the most important theory from GTU examination. 2 to 3 marks question પૂછાય છે. So I have also cover theory part also. Okay, so now I hope it is clear to all of you. So now let me put the value in this equation. Plus 20 into x minus 2 raised to 0 plus 40 into x minus 2 square divided by 2 minus vb is nothing but 228 into x minus 5 minus 40 into x minus 5 no square divided by 2. Now is it clear or not? Please confirm me. Is it clear? This equation is clear to all of you? Okay, fine. चलो आ इक्वेशन તમારે પહેલી વખત ઇન્ટિગ્રેશન કરવાનું. ફર્સ્ટ ઓફ આ ઇક્વેશન તમે ફર્સ્ટ ટાઈમ ઇન્ટિગ્રેશન કરશો. પહેલું ઇક્વેશન લખી આપું છું એના પ્રમાણે તમારે બીજું ઇક્વેશન બનાવો. ઓકે, પહેલું ઇક્વેશન તમને લખી આપું છું એના પ્રમાણે તમારે બીજું ઇક્વેશન. This is your first dotted line, this is your second dotted line, and this is your third dotted line in your form. So first of all, integrate this equation with respect to x. We will get ei into dy by dx. ei into dy by dx that is equals to minus 22 x square divided by 2 plus 15 to x minus 2 square divided by 2 plus 20 into x minus 2 raised to 1 divided by 1. Keep in mind તમારે આનું ઇન્ટિગ્રેશન તો કરવાનું જ છે. That's the reason we will put a value in power of x raised to 0. Is it clear or not, students? X minus 2 raised to 1 divided by 1. Okay. Plus 40 into x minus 2 cube divided by 6 minus 2 to 8 x minus 5 square divided by 2 minus 40 into x minus 5 cube divided by 6. Is it clear or not? Please confirm me. Is it clear or not? Is it clear or not? Same way you need to calculate equation for y. Same way you need to calculate equation for y. This is your equation number A. This is your equation number B. Okay, once you will get equation number A and equation number B, અહીંયા તમે c1 લખવાનું રહી ગયું, પ્લસ c1 આવશે. ઓકે, તમારે આ પ્લસ c1 ક્યાં લખવાનું? એઝ પર રૂલ અહીંયા લખવાનું આવશે. 22x² by 2 પછી લખવાનું આવશે. અહીંયા ક્યાંક લખવાનું આવશે. ઓકે, so now to calculate integration constant c1 and c2, you need to apply boundary condition. And boundary conditions are that at a point A x equals to 0, y equal to 0. Everybody with me? Please confirm me. Please confirm me. Yes or no? And similarly, at a point B, can I say that x equals to 5, but again y equal to 0? due to the hinges, due to the roller support. So we have a two boundary condition. We have a two boundary condition and two integration constants C1 and C2. All of you are able to calculate C1, C2. Please give me a quick check. All of you are able to complete this example? Yes or no? All of you are able to complete this example? Please confirm me. Okay, so we will conclude here. Macauly's method as per specifically for simply supported beam and a cantilever beam. Okay, અહીંયા હું Macauly's method simply supported beam અને cantilever beam માટે પૂરી કરું. Any questions? Any question? કોઈના question પૂછી શકો છો? I think આપણે cantilever beam start નથી કર્યું, બરાબર? May I right? We don't have start cantilever beam. નથી કર્યું cantilever beam start. Okay, fine. So now આજે આપણે આટલું જ રાખીએ છીએ. ઓકે, મેં તમને જે એક્ઝામ્પલ આપ્યા છે એ એક્ઝામ્પલ્સ એકવાર પ્રેક્ટિસ કરી લો. કાલના લેક્ચરમાં આપણે કેન્ટિલેવર બીમ સ્ટાર્ટ કરીશું. ઓકે, અને લગભગ કેન્ટિલેવર બીમ 80% કાલ પતી પણ જશે. ડોન્ટ વરી, એ બહુ નાનો ટોપિક છે. ઇફ યુ આર એબલ ટુ કેલ્ક્યુલેટ સિમ્પલી સપોર્ટેડ બીમ, all of you able to calculate cantilever beam also. Don't worry about it. હું કરી દઈશ, આજે સેન્ડ કરી દઈશ. Don't worry. No one. Okay, don't worry. Fill the Google form. હું કહું પછી લેવું થજો.